This is the umpteenth time I've recorded this, so hopefully everything works this time. This is day 2 of the topic 7.4, and we are going to look at frequency as a feature of sine and cosine functions, and we're going to look at an application where we can actually create a graph and then create the function from that graph or the data table that we have. Whoops. So frequency, by definition, is the reciprocal of the period. And you remember that for sine and cosine of x, so this would be what would be represented on our unit circle if x is in radians, that every 2 pi we would start repeating ourselves. So 2 pi is the period. That means the frequency is 1 over 2 pi. So once every 2 pi, the pattern would repeat itself, or the cycle would repeat itself. And look at the blue graph down here. So here's the 2 pi starting at 0. You can see that's a sine function because 0, 0. So once every 2 pi, the pattern starts repeating itself. Now on the second one, the orangish red one, that's the graph of negative sine over 2x. And that has a period of pi. You can tell that from the graph, right? But if you didn't know that, you didn't have the graph in front of you, you would say, this is b. B is 2. So the period is 2 pi. You could say divided by 2, or you could say 2 pi times the reciprocal of 2, which is 1/2. So whichever way you like to do that, the period is pi. So that's where that comes from. So the frequency, let's do it over here. The frequency would have to be the reciprocal of that, 1 over pi. So once every pi units, the pattern repeats itself. That's what frequency is all about. That you'll see in physics with pendulums. Electricity uses a lot of cycles. Frequency is important in that too. We're going to look at how we can go about graphing some of these functions. And honestly, when you're looking at a function like this, you could look at this. This would be the amplitude, so that would be 5. So I know my highest point would be 5, and then if my midline is 0, which it is right now, y equals 0, the x-axis. And the minimum value would be -5. I can see that. Also, if you think about, if you're not sure about that, this part of the function right here, the biggest it can be is 1. The sine of anything, the biggest the sine of anything can be is, that would be your maximum. And you remember on your unit circle where that happens? Where is the y1? Up here, right at 90 degrees. So that's where it's at its maximum. 90 degrees. Remember that? Okay. So then the minimum, -1, would be down here. That's where your y value would be at its minimum. That would be at 270 degrees, or 3 pi. Let's see, 3/2 pi. Yeah. Okay. So now that we can find the maximum and minimum values, we can find, we just, 1 and -1, we would just put it into this equation and multiply it all by 5. So that gives us the maximum minimum that y can be. The amplitude is, again, is 5. The period, again, you can remember this isn't quite right. The period is 4 pi because I would take the 2 pi, multiply it by the reciprocal, or divide by 1/2, same thing, and I would get 4 pi for my period. So the frequency would be once every 4 pi, That's what this should say. Once every 4 pi, here's the pattern would start repeating itself. Now we talked about minimum and maximum. The zero values, those are important. You notice here that if we start at 0 and end at 0, halfway between, you know it's going to cross the line again, right? It's going to go at 0 again. So that's, if you start at 0 and end at 0, that'll happen. We're going to skip that one. Now let's look at the graph of this function here. And I'm going to draw over here how we got, make a little table and put in how we got these values. So this math teacher has a clock, like of course every math teacher would have, centered at the origin of a coordinate system. See the coordinate plane behind it? So the hour hand on the clock is 5 inches long. So it's 5 inches from here to here. And we want to graph the relationship between x and hours. So this is in hours, and this would be, let's see, y is in inches. This is a little unusual graph, but it's interesting. And this is the inches between the horizontal axis and the tip of the hour hand. Okay, so it's basically the y value, right? The y value of where my hour hand is at a certain hour. So this is the hours. Where are we going to start? From midnight? So midnight, this would be midnight, would be 0. So at midnight, where would my hour hand be? What would be the y value? How far would it be from the x-axis? Well, it would be 5 inches. So at 0, sorry, I put it in the wrong place. It would be 5 inches. And I might go ahead and go, well, the next thing would be at 3 o'clock, 3 hours from midnight. Where would the y would be over here? So it would be right on the x-axis. So it's 0 inches from the x-axis. And then at 6, the end of the hour hand would be at negative 5 inches. Seems kind of weird, right? But it is. And then at 9, I'd be back to my 0. And then at 1 o'clock, which would be 12 hours later, I would be back at the 5 again. And if you did this for another 12 hours, you would have it from midnight to 11:59. We're only going to do the first 12 hours on this graph. So it looks kind of like this. Okay, you could do it again and it would just repeat itself, right? Because the period now we see is 12. So the period is 12. That means I could get my equation because I have amplitude. I know this would be like a cosine function because normally it would be 0, 1 for the cosine. Oh, wait a minute. Normally at degree 0, the cosine would be 1. That's what I meant. Okay. So the period would be 2 pi over b, flip-flop around, b equals 2 pi over 12. So my period would be pi over 6. And I'm going to use my cosine function. So y equals my amplitude, which is 5, cosine pi over 6, and I would just multiply that times x. So x is the hours that march on, right? And this is showing you the same thing. This shows you the 24-hour graph if you want to do it. It explains everything that I just did. Now I want you to try this one on your own. I did start, so this is the inches between the horizontal axis and the tip of the minute hand. So this time we're looking at the minute hand. That's the longer hand. It's 8 inches long. And we're going to graph the relationship between the number of minutes from noon. It says until 3, but I'm just going to do 1 hour because I know 60 minutes is a period, one cycle. So this is inches from the x-axis. So go ahead and try that and see what you come up with. And see if you can come up with the equation too. It's just asking for the period, but actually I want you to find the equation. What I did was I found the amplitude was 8 and the period was 60. So I set that equal to 2 pi over b, which makes b equal to pi over 30. And normally a cosine would be 0, 1. So I know it's cosine and not sine. 0, 0 would be sine if it started. So I did pi over 30, cosine 8 cosine pi over 30 times x. Now, oh, I thought I erased some of this. Let me see if I can get that on here. I don't know if my tools aren't working exactly right. So I'm not sure if I can erase this. I don't think it's going to work. Okay, so you'll just have to, well, I did some other fancy stuff. Oh, now I can write on it. Let me stop that and fix that. And we'll come back. I have to just ignore my writing on here. I thought I got it all off, but I'll show it to you what I did here. So if we're looking at f of x, at this function right here, and then we're also looking at g of x, which is this graph right here, I can compare period and amplitude. And I think amplitude is the easiest one to find, so I did that first. Amplitude is whatever, the absolute value of whatever is in front of your function cosine of blah, 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 or sine of blah, blah, blah. So 4 would be the amplitude here. The amplitude on the graph, if I haven't shifted it, meaning my midline is my x-axis, the amplitude is just your maximum value. Now, if it is shifted, you want to take the absolute value of the max minus the minimum, in other words, the distance between those, divide it by 2, and that would be your amplitude. We're going to do this in the next section. You can't really see what I did there on the period, but it does say right here. The period, we would take 2 pi, divide it by, or multiply by the reciprocal, whatever the b, whatever's in front of the x, and we get an 8. So if you don't like to mess with fractions and you're thinking, oh, I'm just going to do the reciprocal, it's a little cleaner that way, but you're doing exactly the same thing. So the period here is 8. The period on this one, I just look at the graph, starts at 0, kind of goes up, and comes back at 4. So the period there, just real quickly, is easily 4. Now, what if I wanted to find this function? That's a good challenge problem. Y equals 4 times something. Notice it starts at 0, 0, so I'm going to use the sine function. I found the period down here, so I could set that equal to 2 pi over b, do a little rearranging. B would be 2 pi, flip-flop, right? Divided by 4, so b would be pi over 2. So I would do pi over 2 times x, my function. And I would probably put that into the calculator just to double check to make sure I didn't mess something up, because sometimes that happens, right? Sometimes it happens. And we did the same thing here. We already did that. Now, here's the summary of today. When I have a general equation for a function that looks something like this, or something like this, I can say the amplitude is the absolute value of A, and I can say the frequency is B over 2 pi, which means the period is 2 pi over B. This graph right here is this function, y equals 1/2 sine of 4x. 1/2 would be the amplitude, and you can see right here, the highest and the lowest is 1/2 minus the negative 1/2 would give me 1, divided by 2 would give me 2, 1/2. So the amplitude is 1/2. Because the midline is the x-axis, it's my maximum value. There's my midline. And then the period, where does it start to repeat itself? Well, it looks like at pi over 2, it starts to repeat itself. And I could also do, well, it's 4 here, right? So that's b. So I could say the period is 2 pi over 4, which is the same thing as pi over 2, which I found from looking at the graph. So the goal here is, can I look at an equation and find the amplitude, period, frequency, possibly even the maximum minimum points and the midline? Hopefully you can do that. And can you look at a graph without knowing the function and come up with those same features? And possibly even look at a graph and get the equation from that graph. That would be a good goal to put before yourself. The good practice would be try the 7-4B Math Excel. And then if you have any questions, go see your teacher, talk to a friend, see what you can find out to help you learn all these features of the sine and cosine functions.